Good morning, sir. Sir, am I audible? Hello, sir. Am I audible?
ட்ரோன் பண்ணலாம் ஃபார் அனிமல் சர்வேலன்ஸ். ஓகே, எலிஃபண்ட் கிராஸ் ஆயிருக்கு ப்ராடக்ட்ல. ஸோ நம்ம அதுக்கு ஒரு ஸ்பைன் பண்ண ப்ராஜெக்ட் தான்.
It's no problem.
Sir, am I audible? Sir, am I audible? Till now, did anyone talk in the meet, sir? Because I couldn't hear anything. No audible. Okay. In the meet. Okay. Okay. So, good morning, everyone. Hope I am audible. Yes. Can we proceed now? Hope I am audible. Yes. Yes or no? Sir? Sir, am I audible? I'm able to hear. Am I audible? Please tell me yes or no so that I can proceed. Is the voice audible over the meet?
I'm audible.
Okay. Thank you, ma'am. Thank you. So, good morning, everyone. Thanks a lot to Agni College of Technology and the Department of Chemical Engineering and Dr. Shyam for giving me wonderful opportunity to talk to students of Agni. So today's webinar is on developing online repository of business plan or prototype developed and way forward plan. So myself, Dr. Deepta R. So from the Department of Information Technology from SRM ISD Ramapuram campus. So today, before moving on to this topic, so let me just revise you like because this is a very important concept in all domains. So for all domains of engineering, so like be it any branch, so this sort of like a business model or prototype and developing the repository will be very useful for industries. So because once we complete the graduation, so we will be entering into industries or higher studies. So for those who enter into industries, so like company, when you start working, so all these things in real time will be experiencing in companies. So that is why we say like this topic is like industry 4.0 related topic. Right. So before going into the topic, so we need to get some basic introduction about what is software and then what is software engineering, how software engineering is used in computers. So how it is important to company point of view, then how to do the testing, then what to do the project planning, business prototype, how to develop it, how to develop the online repository. Okay, then finally how to go in for the way forward plan. So this is going to be the flow for the next one. So software. So because this topic is more towards industries. So before we start this topic, let us first visualize that we are all working in industries, okay, and we are assigned a particular project. Okay, because what happens in industries is like, so you will be given some projects to develop. Okay, so it can be in any field, IT field or EC, electrical, chemical, whatever the field. So you will be given some projects to complete and there will be a particular deadline. Okay, and to develop a project, there will be some lot of people involved, starting from software engineers to project leads to team heads to accounts line. So like that, so different people will be involved and each of them will be doing their own work. Okay, so finally they will integrate all the results and they will come up with the complete software project. And this one we are going to deliver to the customer. See, all the aim in all companies, industries will be like to get some ultimate customer satisfaction, end user satisfaction. So the company can grow only if it gets more and more business. So when we will get more and more business? When the customers are satisfied. So when the customer is satisfied, ultimately the company will get more and more projects and in turn the company also grows. So always in all industries, the ultimate aim, the ultimate motto will be end user satisfaction. Okay. So keeping that in mind, we are going to start the presentation with the basic term of what is software. Because this topic is related to software engineering. So slowly we'll get introduced to the topic after seeing the basic definitions. Okay. So software. So software is like a set of instructions. So software, see, now we are working in Cisco WebEx platform. What is this? This is software. Okay, now we are seeing a PPT. What is this? This is software. Software is a set of instructions, data, programs, everything. So it is used to operate our computer and we are going to execute some tasks. So the purpose of the software is it's a set of instructions to execute some particular task. Okay. So software is total opposite to hardware because hardware is physical aspect. You can touch and feel. See, keyboard is a hardware, mouse is a hardware, monitor is a hardware. Touch and feel that. But when we say software, Cisco WebEx is a software. This PPT is a software. We can't touch and feel that, but this is having some set of instructions to execute a particular task. Okay, so this is a general term. So software is a general term. So we are going to refer to some applications, scripts, programs, everything, so that can run on a particular device. So that is the basics of it. And all what we work in a system is a software. See, like all these things. PowerPoint, Word, Windows, Java, Linux, operating systems, Gmail, Chrome, Apple, Notepad, all these are Excels, all these are software. Even our antivirus is a software. Right. So then comes what is software engineering. So now that so, shall I, like I'm clearing some sort of background. Okay, so software engineering. So then comes what is software engineering? So software engineering is an engineering branch. So this is an engineering branch. Here we will deal with the development of software product. How the am I audible? Am I audible till now?
Yes, ma'am.
Okay, so software engineering is like so this is the engineering branch. So here we will be developing the software product. Okay, so software product we are going to develop some set of principles, methods, and procedures. So this is what we are going to discuss in this topic. How this is being developed. Lot of models are there. One such model is the prototype model, which is our today's topic. Okay. So outcome of software engineering. So for anything what you develop, there's some outcome or result. Okay, so outcome of software engineering is reliable software product which the customer can use. See, always we will keep in mind our motto will be end user satisfaction. Customer satisfaction. That's very important.
Sir, நாளைக்கு பார்த்துக்கலாம்
The
சார்.
outcome of software. So now when we go into any stream, there will be some IEEE definition, Institute of Electrical and Electronic Engineers. So that definition will be available. So I am able to hear some background noise. Can it be muted, please? Okay, thank you. So IEEE definition of software engineering is like, see, when we go for software engineering, so it is like application. So we are going to develop a systematic product. We are going to develop a disciplined product, quantifiable approach. We should be able to quantify it. So how many, how many months, what is the duration, what is the cost? So quantify. So we should be able to quantify everything. So it will relate to the development, operation, and maintenance of software. As I told you, we are imagining that we are working in industries. We are given a particular task. We are given a particular project to develop. Okay. And that project has to be developed within particular period of time. Okay. And after delivering the product to the customer, we are going to get the end user satisfaction. Customer satisfaction is very important. So here some realities. So here we need to understand the problem before a solution is developed. Because say for example, we are all seated in some campus. So I am in SRM campus, you are in Agni campus. So this building, how did this building come up as such? So directly they can't go and start constructing the building, no? So they need to develop some blueprint. Like similarly here, so we need to develop some software solutions model before developing the original solution. Some prototype, business prototype has to be developed. Business model has to be developed before building the solution. See, once we are given the problem, so we need to understand the problem. This problem will be given by the customer, okay, end user. So we need to understand the problem first. Then before going in for the software solution, so we need to develop the prototype. So that is what we are going to discuss today. So we are going to develop the prototype for the project. Then the software solution will be built and accordingly it will be tested and maintained. So here design phase is very important because this constitutes the 80-20 rule of software engineering. So design of the software product is very important. And this should exhibit very high quality and maintainable. So after delivering to the customer also, this has to go past the periodic maintenance. So even for a small example, we are assume we are going to buy some air conditioner, AC, or water purifier, or some refrigerator, or some TV to our house. Okay. So after buying some product, what we will do? So they when selling the product itself, they are asking some category of AMC, annual maintenance contract. Whether you want to go for AMC or not, 1 year period, 3 year period, like that. So if we sign the AMC, what they will do in that 1 year period, say for example, 4 times or 3 times in a year, they will come and maintain the product. So that is what we say, software should be maintainable. That maintenance is very, very important. Because after delivering to the customer also, we need to go past the periodic maintenance process. Okay. Then comes layer technology. So as and then and there, we can't build the software product as such. The prototype has to be developed. So for that, there is some layered approach here. So tools, methods, process model, quality focus. So here we are giving priority to the quality. So it should be like quantitative assessment also should be given, and quality is very important. There should be no compromise in the quality. So this is a layered technology. So here the foundation of any software engineering product development is the process layer. This layer, process layer, which will do all the processes, like starting from the analysis, design, coding, testing, maintenance, it will be taken care here. Okay, so this is developed like a framework. So we need to go past the different phases here for effective delivery and maintenance. Okay. So here we are going to go past the technical content, how to do, what to do for building the software. How that 5W and 1H, no? What, when, why, whom, where, how, all these things should be answered in the requirement specification itself. Then only we can start the developing the software product. Okay. So when we go for the methods which encompass the broad array, so here the communication is important, requirement analysis, design modeling, program construction, testing, and support. Support is what I told you, maintenance. So after delivering to customer also, this periodic maintenance should be available. Okay, so software engineering tools, we can have like automated tools or manual tools also for the test processes. Say for example, lot of automated tools today nowadays are available like QTP, Selenium, and so on. Different tools according to different needs are available. So we can make use of these automated tools, or we can go for the semi-automated tool wherein the manual support also may be required to develop the test plan and test cases and all, or we can go for the complete manual testing process also. But in complete manual testing process, naturally, because the entire human labor is involved, the cost and time is going to increase. So when the tool is available, this tool, automated tool is available, we can go for the specific method to develop a software product so that there is no compromise on quality. So that quality is very, very important. And essence of practice followed in all business prototypes is like, first solution is we have to understand the problem. So for that, we need to do communication and analysis. So first, requirements gathering and analysis. So we have to analyze what is the problem about, analysis. So here generally we used to draw some rational rows diagrams for this using some tools are available. So here we will be generally drawing the use case diagram. Use case diagram is like we can have an interaction between what are the different use cases and who are the different actors, so that we can know what is the project about, what the user is going to develop, what is the who are the users, what is the use cases, what they are going to develop. So all these things we can know in the analysis. Then after understanding the problem clearly, we need to plan a solution. So planning should be done. So this is what is called modeling. In like real time example, our college building. So we used to say it as blueprint. That architecture. So architectural people specialized in BTech architecture, they will be developing VR. They will be developing a prototype of the business model. So this model is important for developing a software solution also similarly. So based on the model, we are going to draw the use case diagram, class diagram. So class diagram is software design. So we need to understand the software design. Design phase is very important. Most of the effort should be given here. After the design is over, we have to carry out the plan. Already we have planned, so we have to carry out the plan, means code generation. So that code can be in any code, like any language, what the user is comfortable. So the same, these diagrams and all what we draw is all generalized. So use case diagram, class diagram, sequence diagram, collaboration diagram, all these things are generalized. So using this diagram, we can develop the code in any language, and our software supports that also. Rational Root software supports that also. Okay, so we can develop the code in C or C++ or Java or Python or whatever. So even in .NET also we can C#, any language, any framework, we can develop this code. Skeleton of the code will be available for testing. So once the code is generated, next we have to examine the result for accuracy. Means we have to check, we have to test whether what we have done is right or wrong. So accuracy testing. So testing of the software product is important. After testing, it has to be delivered to the customer. So we have to check the quality assurance. So the quality of the software product that is delivered has to be checked with the customer. So quality assurance testing, we call it as SQA. Okay, one by one we are going to, so now we have seen the broad overview of a business prototype. So one by one we are going to discuss now these 4 steps. So we can we can explain them on our own by understanding. So understand the problem. So first step is we have to understand the problem. Communication and analysis is important. Here we want to know who are the stakeholders, who are going to use our model. So when developing any business prototype, so first question is we want to know who will be using, who is the end user, stakeholder. Then what are unknowns? So what are the known facts? What are the unknown data we require? And what data, function, feature, everything is required to solve the problem. What is required? So that's what I told you, the 5 W and 1 H. What, why, where, when, whom, and then how. So if we answer all these things, automatically this communication and analysis is over. So then we have to know whether the problem can be compartmentalized, whether we can break it into the problems which we need to identify. Then if it is breakable into sub-problem, we need to see how we can represent the smaller problem, which is easy to understand. The ultimate aim is the customer, when the product is delivered to the customer, that satisfaction should be there. Always one motto only in software engineering: customer satisfaction, end user satisfaction. Okay, then we are going to check whether the problem can be represented graphically. So why we are going in for this concept is, rather than explaining in sentence after sentence requirement, that SRS, software requirement specification, no? Rather than giving in continuous sentences, if we are able to represent something graphically through diagrams, it will be very easy for the customer to learn about it. Also for the developer who develops the product. See, there is one small example, no? One picture is equal to 1,000 words. So that's what we say. So 1,000 words, rather if you give one picture, so that picture will explain everything very easy. So that is why we always say the problem, we have to represent it graphically. So here we can use again some tools like Minitab tool is available, Vika tool is available. We can make use of already the available tools and all to develop the graphical representation of the software. Then we have to identify whether the analysis model can be created. So based on the requirement gathering, that is communication, end of communication, we have to analyze whether the use case diagram is easy to develop for this given question. So once we have framed that understanding phase is over, next will be the planning solution, plan the solution. So here we have to plan in the sense design. So here we are talking about the design phase of software engineering. So we have to plan the solution. So when we plan, we have to ask ourselves some questions like, have we seen similar problem before? Because if there is any similar problem, we can take some idea from there. So whether there are any patterns, whether there are any frameworks already being developed in that, whether there are any functions, whether any features, new features are required, or whether some existing ones can be reused. So that is what we call the term as reuse. Reuse means like we are using what is already available, inheritance, the base concept of inheritance. Because when we reuse something, automatically we are saving a lot of time, right? So when we reuse, we are saving time and cost. Automatically, when the time and cost is saved means the complexity. We are aware of some two concepts like time complexity, space complexity. That is the base idea of all DAA papers. So the time complexity will automatically get reduced. So that is why we see whether any reuse is possible. Then we are going to identify whether similar problem is solved. If it is solved, whether it can be reused. Then whether any sub-problem we can frame that from the given problem. If so, what are the solutions? Whether can be represented in the solution through implementation, whether design model can be created, can analysis model can be created again. So by refining, because see this sentence, can analysis model be created? Already it is created only, but why it is given again is like, see, when we are directly dealing with the customer over the period of time, the customer requirement might change. No, initially the customer will give one set of requirements. After some period of time, he may change the requirements also. So whether this analysis model is capable of coping up to the changed requirements. So all these things we frame, we ask these questions ourselves. So once we are comfortable, so then we start the design phase, planning the solution, design. So design in the sense in developing the UML class diagram. Okay, the next is about carry out the plan. So once this design is over, the next step is implementation. We need to carry out the plan, implement it. So implement it through some code generation. So source code traceable to the design model. So then when we have to develop a component diagram and deployment diagram here. So whether component part is probably correct, whether the design has been reviewed, whether it's better. So all these questions we want to ask ourselves and develop the component diagram and deployment diagram. Once the execution source code generation is over, next step is we have to examine the result. So this is where we get the concept of software testing, which is a separate, a very big stream. Okay, so there is a separate testing department working with each project. So there will be some test engineers. So so their work is to only doing the testing process. So they are going to test, but this is very, very important because based on this report only, we will deliver it to the customer. Okay, so whether it is possible to test each component. So whether we are going to test the component separate as unit or as integration or as system. Three types of testing is possible here. Unit testing means starting level, integration combination of different units, and systems, testing the system on the whole. Okay, so this testing we need to do very carefully, as I told you, using two methods, either using some tools or using some manual testing. So manual testing obviously will require a time and cost will be more of human labor. So because test case, test plan, everything we are going to generate and also run the test. Or we can go for semi-automated testing also. Means we can develop the test report and test phases on our own, and we can use the automated tools available to run the test. So it's a combination of manual and automated. So semi-automated testing also. So once that is done, next it has to be validated for verifications. So that is what we call two V's of software engineering: validation, verification. It has to be validated, it has to be verified, then it has to be verified. Okay. So finally we say how it all starts. So safe home, like keeping any business in mind. When developing a business prototype, we need to check whether any defect is available in the existing application. Because existing application itself, if there is defect, so we need to first correct it and then come. So like I think we are familiar with one like phrase, no? Suppose we are correcting one error, it will give rise to new errors. That's what they say. Suppose we correct one error, it will create new errors. So whether any defect is available, first we want to correct it. The process of correcting this defect will give rise to new defects. So that defect also first we need to correct it, test it. Then we need to adapt a legacy system for software engineering. So changing business environments. So whenever our business environment changes, whenever the customer requirement changes, we need to adapt to legacy system. Then we need to start the feature of the existing application. So we need to extend the function because already some existing application is available. We want to extend it. We want to expand it. Then we are going to create a new product or service or system based on what we have done so far. Based on the previous steps, analysis, design, testing, we are going to develop a new software product. So this is what the phases of software engineering. So planning, designing, development, testing, deployment, maintenance. In any software engineering business prototype model, we will have to go past all these phases. So first step is planning, end user communication, involving analysis also. The next is designing, development of the class diagram. So here is very, very important. The next is development, means code generation, implementation. Next is testing, as I told you, whether we are using going in for the automated testing or the manual testing, or like one more category also, whether you are going to test the unit separate or like integration testing or the system as a whole. We are going to develop it, and deployment. Once it is tested, we have to deploy it, means deliver it to the end user. And finally, we are going to do the maintenance. So this is what I told you, that AMC contract. After delivering to the customer also, we have to go and check the maintenance periodically. So that is, then only we will get the customer satisfaction, right? So when developing any software product through business prototypes, these starting from here requirements. So these phases we have to come first. So first requirement gathering, analysis, design, maintenance. So any update is there, we have to come. So this statement, like these phases back and forth, we have to go a number of times before deployment, testing, code design. So all these things are must when developing any software product using any model. Okay, so once that is done, then the role of the software project management in developing the business prototype. So here, the project management, they will be concerned about what activity we are doing, because there will be a separate team working, which will ensure that the software is delivered on time, within budget, on time and within budget and on schedule with the requirements of the organization. See, the customer has given some requirement, whether the product also is like on par with the requirements custom, then whether it is delivered on time, then whether it is meeting within the specific budget. So all these things, the separate team work, software project management. So because software development is always subjective to budget and schedule constraints, depends on the budget what we involve and what the time schedule, like whether we are able to finish within a particular deadline, particular milestone. All these things are set by the organization and development. Because when we extend the time, suppose for example we are developing the best product, okay, best product, but it has exceeded the budget and the schedule, it has exceeded the budget and or it has crossed the schedule, that means it's of no use. No, it has crossed the schedule means it is no use to the customer. It has crossed the budget means the company is at a loss. So that means we also want to make profit. At the same time, we also want to deliver within the budget and within the time. So that is why this project management is very, very important. So success criteria is we want to ensure all these things. So deliver in the agreed time. So this has to be delivered to the customer at the agreed time or before the agreed time. And we have to keep all the costs within the budget, because this should not exceed. If this exceeds, no problem to the customer, but the company is at a loss. So then how we can run the company? Okay, so this cost also has to be within the budget. Okay, then we have to deliver the software which meets the expectation. That is what I told you, the end user customer satisfaction is very important. Customer expectations should be met properly. And we need to maintain a coherent and well functioning development team, which will do the periodic process even after delivery. Maintenance has to be done. Okay, so software project management, in that software management distinctions, the product sometimes will be intangible because the software cannot be seen or touched. Okay, we can't see this PPT, I can't see, I can't touch, but it can be felt on me. The same way, software project managers can't see the progress by simply looking at the artifact, like what is being constructed. If the project managers look at that, they can't simply understand it. So for that, we have to develop the proper documentation. So documentation is very, very important. And in our software, Rational Pro, there's a separate tool for that, Rational Requisite Pro. It's called Rational Requisite Pro. A separate software is available, which will do all these like documentation. What's the precondition? What's the post condition? Like everything, it will keep track in that. Okay, so many software projects are one-off projects. So means large software projects are sometimes different because sometimes see the project itself we may have to break it into smaller solutions, smaller sub problems. Each sub problem we will solve so that directly we can get the like solution to the main problem. So even some managers who have previous experience, they will feel it difficult to solve a bigger problem. So the idea is we are going to break the problem into sub problem and then solve it. Okay, so still we can't predict like what is reliable, what is not reliable unless the testing is carried out properly. So that is why when doing this like Paka project management, two factors are affected: the company size and the software customers. So company size in the sense the proper manpower in the company should be maintained, and who are going to use the software, that software customer, that also has to be kept up of properly. And any like a continuation. So software size is important, software type, what type of software, what's the organizational culture, because that like they are all going to work as a team. The team cooperation should be important. So organizational culture, software development process, all these factors are very important and means a lot to the project manager in different organizations because they all work in, each person works in different ways. Okay, and when we go for the life cycle activities, some very important phases, proposal writing. So this is what I told you, the documentation. Because whatever we develop and give to the customer, okay, it's working, but we also need to maintain documentation also. That is called proposal writing. This is the first stage. So any item or any like work you want to carry out. So there will be like team working with the proposal writing. So their work is only documentation. So there's a separate team specialized in each stream. So they are going to describe the objective and how it will be carried out. What's the objective? How it's going to get carried out. For these phases, it has to. Next is about the project planning. So here we are responsible for planning, estimating, scheduling, development, assigning people to tasks. All these things have to be planned very carefully by the project managers so that there is no clash in the time or the budget between them. These two are very important, time and budget. Okay. And when we go for the life cycle activities, we also need to keep in mind the risk factor, risk management. So that's what we call risk management and maintenance, RMM. In all business prototypes, risk management is very important because any project we develop, there are certain risks. Suppose, like a best example of a risk is scalability. Suppose we are given a particular link, online link to develop, like to open up. Okay, so there will be an like constraint on the upper limit, no? So like how many customers can, how many participants can join. So like that, there will be some constraints. So that is what scalability. So there are some potential risks if it is dealing with a large enterprise. So this risk assessment is very important because otherwise it will affect the entire project. So we have to monitor the risk and we have to take action then and there when the problem arises. So this stream is called risk management and maintenance, RMM. Then the next one is about people management. So people management is very important role of project manager. So project manager have the role of work for him is he has to choose the correct people for the team and he has to establish the way what they are going to work for effective team performance. Because see, as I told you, one team will be specialized in testing, one will be specialized in the design, developing the design, one will be specialized in some C code or C++, whatever. So which stream they are comfortable, that one they should be allocated so that to get the best team performance. The next one is reporting. So the project report, that is what the test report. So test report, project report has to be like keeping track of the progress of the customer. Like to the customer, we have to give the weekly progress, monthly progress, fortnightly progress, like that. No, so the Paka reporting should be maintained. So for that only some tools again software. Nowadays, this is a computer world, so we need not worry about anything. Already tools are available for everything. We can just use the Rational Requisite Pro and execute it so that this can be documented. Okay, reporting can be developed. So once this, so now that we have learned about what is software engineering, what is software project management, next comes what is software testing. So this is very, very important phase. Separate huge team will work on it. So software testing is the basic process of evaluating and verifying. So here we are going to evaluate, here we are going to verify that a particular software product or application does what it is supposed to do. Means what? we are developing some product, we are developing a particular project or a product, whatever. So this product has to be in compliance with the various requirements that was given. We have to evaluate for that. We have to verify that it is working properly, and we have to also validate that it is doing the correct result, what it is supposed to do. Okay, benefits of testing will be preventing bugs. So through testing, suppose we do the testing and then deliver to the customer, bugs will be prevented. Not even a single bug will be available, and reducing the development cost, because as I told you, the time and budget is very important. So reducing the development cost and improving the overall performance, because all flaws will be corrected then and there. That's the main advantage. So the software testing life cycle is separate. So here first we have to requirements review we have to do, then test plan. So already the product is available, so we have to do the test planning. Then we have to generate the test cases. Then we have to go for the test environment setup where this testing will be done. We have to run the test. We have to get the test report. So this is the complete software testing life cycle. Requirements, planning, we should do test cases, we should develop test environment setup, we should do, and we should run the different tests, and finally we should get the test report. So this is what can be done using three ways actually. So either it can be like using it can be using a automated tool, or using a semi-automated tool also, or using a manual report also. It can be like a combination of all these. So these are all the software testing deliverables. So strategy, scenario, matrix, closure report, summary report, test data, test case, test plan, everything we need to develop. So when it comes for the software development lifecycle, so this we are focusing on the design and development particularly. So design and development and developing the high quality software. Okay, so when it go for the software development lifecycle, as we saw before, 6 stages are there: requirement analysis, design, implementation, validation, also called testing, installation, and maintenance. Okay, so software development lifecycle, these are the different phases involved here. Okay, the next one is about verification and validation. What I told you, 2 V's are very important. So requirement gathering, analysis, design, and system design, software design, everything comes under verification. And the coding, unit testing, integration system, and acceptance testing will come under validation. Right. So once this is done, this software development life cycle in detail, they have given about each phase. So which we have already discussed pretty long now. So requirement definition is done by the customer. Next one, analysis is done to frame the initial model. Then design is the ultimate software design, input, output, process, everything it will explain. The next is about the coding. So coding phase, here we will include all the SQA activities, unit test, integration test, everything, whether it is done automated or semi-automated or manual. Here we are going to test. The next one is system test. So whether we are going to like any error is there, if so we have to correct that error. Then finally we have to do, this is a very important, user acceptance testing. So UAT, user acceptance testing, has to be done by the customer. So this is very important. There's a difference. Till now all the processes were done by the company people, but this acceptance test will be done by the customer, or in conjunction with the customer and the developer together. So they have to check whether this software is working as expected. Okay, so then installation and conversion. So like installation, after this is working, it has to be installed in the required destination. So means in the end user site. And also periodic maintenance we have to do. So install incrementally, we have to run it in parallel and turn on the switch and live with it, and go in for proper maintenance of the product. Okay, once this is done, operations and maintenance. So this should be done for years. So corrective, adaptive, perfective. So we should check all these points. So classical SDLC also we have to go for the feedback loop. What is the feedback loop like? So this we should check accordingly. Okay, so then next comes all these points, whatever we have discussed, all these dotted lines are the maintenance phase, because see that maintenance has to be done in every phase. That is why there's a connection to all requirements, specification, design, implementation, everything we have to check properly. So then SDLC models, as we saw, there are different models to perform the software development phases like waterfall model, V model, incremental model, RAD, agile, iterative, spiral, prototype, so on. Our topic is with respect to prototype model alone, so that we will be focusing only on that. So software concept, requirement analysis to be done, design to be done, developing a version, deliver the version, waiting for the end user feedback. So finally, we will deliver the final version to the customer. Okay, so now that we are comfortable with all these things, we finally end up with prototyping. So because it's what our topic is about, developing an online repository for prototyping. So begin with the proper communication. So we have to develop a quick plan for prototyping, like quick design focus and construction of a prototype, and stakeholders' comments are very important, based on which we have to do all these points like in a loop, like repeatedly we have to do all these things. So when to select, like it's very important because general objectives will be there. Detailed requirement will not be mentioned in the prototype model. Efficiency of the algorithm is a concern, and need of the customer. So when it is delivered, how it is delivered is important. So advantages of this prototyping model is it will provide the actual working model itself. And this is very, very important. Customer is highly satisfied, and we can develop the insight and reduce the ambiguity. And finally, we can reduce the risk involved. And so then a disadvantage, say any model will have some disadvantages also. Because here we can have like inappropriate choice of technology, because until it is delivered, we will not know what technology it is being implemented with respect to the customer point of view, and false expectation from the customer side, whether it is finished or not finished, whether it is working according to the behavior or not. These are certain disadvantages of prototype. So here, actually, because of lack of time, so kindly excuse that I am going to go past all these slides, and I will be sharing this particular PPT to Dr. Shyam sir. So because anyone further interested can go through this. So prototyping model is there. So we have to then go for the detailed version of the prototyping model, and the advantages, disadvantages of it, then building option, because as such we can't build it, and once the prototype is delivered, it has to be used by someone. So internet, so like we have to publicize. So now everything is online. Then we have to develop the online repository for our business prototype model. This is the repository, online repository model. Then we have to know what is digital library and repository. Then we have to look for the creation, how we are going to develop the digital repository and online repository, and way forward plan. So way forward plan, how we can plan in advance, involving the public sector, involving the government, and all. Some small examples, real-time examples, business examples, and the benefits of it. And this is the planning example, the project planning, how it will be carried out. So these are the real-time example what I have taken from the source. So project planning, like according to deadlines, when the project is late, what we can do, all such things, and effort versus delivery time, what the effort we give, what's the delivery we get, all these things, and project planning effort allocation, how much percent it has to be spent on each task sets, like how we can do the task sets when we go for the project planning. So this is dealing with the task refinement. So one by one we have to do the refinement process so that there won't be a single flaw with respect to the customer. Then about the estimation. So once the project is developed, we have to go for the proper estimation, the scope for it, how, where, who will use it, people, environment, project, reusable software, and all such things. So the reference, so like this PPT, I've referred Roger Pressman, which is the well-known book for software engineering, Somerville book, and some other online references. So with this, because this was actually planned for 1.5 hour session, because there was a slight delay due to network issues. We are closing as per time, but the start was little delayed due to network. So couldn't complete planned things. So I'll be sharing the PPT to sir. So thank you everyone. So any questions is welcome on this topic. Sir? Sir?
Hello, ma'am.
Yes, sir.
Ma'am, what software can be used for chemical engineers
Like
in
chemical
business development, ma'am?
like software in the sense according to the project they are assigned, sir, because if they are assigned to develop for a chemical engineering, okay, so softwares like Vika is all available, free softwares are available. Vicato environment for knowledge, sorry, Vika, Vicato environment for knowledge engineers, Vika software analysis available, and Minitab also one more software is available. So it will be very apt for all streams, and even in when chemical engineering students go and develop a particular project, as we saw in the PPT, like a graphical, whatever we say, the pictures are important, no, the graphical, the analysis, that we can do very easily with that tool, sir. And for testing purpose, for a product, chemical product, after developing and when it is deployed in online repository, we can always use the automated tools like UTP, sir.
Thank you.
That's a quick test professional.
Thank you, ma'am.
Yes, sir. It's licensed tool, so we can go for the license and we can use that.
Good afternoon, everyone, to one and all present here. Honorable Chief Guest, Dr. R. Deepta, our HOD sir, and all faculties. My dear friends, it is such an honor for me to get the opportunity to thank you all dignitaries. On behalf of the Chemical Department, Agni College, I extend a warm welcome to the people in the gathering. I would like to express my gratitude to all the esteemed delegates of the webinar for their presence of the contribution to make their webinar a great success. I extend my gratitude to our honorable chief guest, Dr. R. Deepta, to take time for her busy schedule to raise the event. Thank you for inspiring and encouraging us with your words on this special day. Hope we all gain some knowledge about developing online business plan. A special thanks to Dr. Srinivasan Alavanda sir, a principal of Agni College Technology, for providing enough support to make the webinar successful. I extend my gratitude to Dr. P. Murugan sir, head of the chemical department, and faculties of the chemical department. Thank you for everyone once again for making it a great success.
Thank you, ma'am. And thanks a lot to Agni College of Technology and the Department of Chemical Engineering, Agni College, for giving me a wonderful opportunity. Thank you.